Hello and welcome. Today, we are going to learn something very interesting: the maximum power transfer theorem. This is a powerful concept that helps us understand how to get the most out of an electrical source. Now imagine this. You have a source, like a battery, and you're trying to power a device, maybe a resistor or a circuit. Wouldn't it be great to know exactly how to connect things so that the device receives the maximum possible power from the source? Well, that's exactly what this theorem explains. The maximum power transfer theorem simply says this: maximum power is delivered to the load when the load resistance is equal to the internal resistance of the source. In simpler terms, the resistance of your device should match the resistance inside the source itself. That's the balance point where power transfer reaches its peak. Let's understand this with a simple circuit in mind. Picture a voltage source connected in series with two resistors. One is the internal or source resistance, and the other is the load resistance. The current flowing in this circuit can be found by dividing the source voltage by the total resistance. That is, the source resistance plus the load resistance. Now, power in the load depends on two things: the current and the load resistance. When we calculate it, we find that the power delivered to the load equals the voltage squared, multiplied by the load resistance, and divided by the square of the sum of both resistances. But don't worry about the mathematics. Here's the key idea. As we change the value of the load resistance, the power sent to it also changes. When the load resistance is very small, power is low. As we slowly increase the load resistance, the power begins to rise. It keeps increasing until it reaches one special point, the point of maximum power. If we keep increasing the load resistance beyond that point, the power starts to fall again. So what happens at that special point? At that point, the load resistance is exactly equal to the source resistance. That is the beautiful balance where maximum power is transferred. Now, in most circuits, we use something called a Thevenin equivalent. That means we replace the entire network with one simple voltage source and one single resistor in series. We call them the Thevenin voltage and the Thevenin resistance. When the load resistance equals this Thevenin resistance, the circuit delivers its maximum power. And if we write it in words, the formula for that maximum power is: the maximum power equals the Thevenin voltage squared, divided by 4 times the Thevenin resistance. That's the highest power the load can ever receive from the source. Let's quickly go over the steps for applying the maximum power transfer theorem. We shall see that directly with an example. Stay patient. Follow and make sure to invite your friend to follow this page for more interesting lessons.